Okay, starting with the problem set for lesson 3-4 combined. Everything's got to be formula, substitute, and evaluate, right? The real important question is what did you use, what was the calculation of your base? Because that is kind of something that was new yesterday. Gab, what did you use for base?
I got 9.4.
Why 9.4?
Because I added 3.3 inches and 6.1 inches.
Did you guys remember to add those two pieces? Okay, that's your entire base. It's 9.4. Times Karen, what's the height? Karen, what's the height?
1.4.
Divided by 2. Punch it into your calculator and you should get 20.68 square inches. Raise your hand if you got it right. Okay, let's do number 2.
I got that right. I actually did I did half this time, so I got the same answer.
That's fine. Yep. I kind of like this formula better because it just punches into the calculator easier. All right, number 2, same formula, A equals BH over 2. What did you put in for the base on this one? That's another one that you have to be very careful of. Jay, how many put 13? Be careful, it's not 13. Because 13 would get you the area of this entire triangle, and we don't want that. Okay? Okay, let's learn from this. This is my original shape here. In order for me to figure out this shape, I need the altitude, which is 12. So I definitely need this number. I don't need this number, and I don't need this number. I have my base, I have my height. Those are the numbers you have to substitute in. They put these two numbers in here to see if you really know what to do. They want you to be able to differentiate what you need from what you don't need. Okay, so if you do 8 and 12 divided by 2, you can knock out 2 and 12 if you want. You wind up with 48 square feet. If you didn't get it, it's fine, but learn from your mistake so you know what to do the next time you see it. Okay? Okay, number 3, I'll just read off the answer. If you need me to go over it, I will. Number 3, if you do base times height divided by 2, you'll get 768 square inches. Raise your hand if you got it. Okay, go to the next one. I do want to show this to you because it's multiplication of fractions all over again. And we've got to practice it. Okay, so my sides of my playroom. 4, it doesn't matter which you're calling what. We'll make that 4.5 feet and 2.5. If you have it reversed, it's okay too. What formula did you use for this? CC. Yes, use the one with the fraction. Because we're going to keep our answer in fractions, and we're going to do everything in fractions. Did anybody convert it to decimals? If you did, you'll still get the same answer, but I want you to keep the fractions because I want you to practice it. Okay, let's substitute in. The base is 2.5. And again, you could have this reverse, it's okay. And 4 1/4. What do I have to do next? Peyton.
Make it into an improper fraction.
Yes, you do. When you do that, 2.5 becomes 9 over 2. 5 over 2. What about 4 1/4? Brandon, what'd you get for that one?
I got 5. Oh, no, I did it back right at 17 over 4.
17 over 4 is what you should have. And then unfortunately, you can't cross-reduce anything. So as long as you have a calculator, you'll still be okay. It's just going to be 5 times 17 times 1, or just 5 times 17. And that gets you 85. And then 2 times 2 times 4 gets you 16. But you can't leave it like that. You have to change it back into a mixed number. What'd you get there, Gabs? If you didn't get it, do it now. 16 goes into 85. Can you do that readily in your head? One more. It goes 5. Pate, did you get the final answer?
5 and 5/16.
5 and 5/16 is a full snow cone. Inches squared. I'm sorry, feet squared. Okay, that was a tough one. Again, if you didn't get it right, learn from your mistake. Get it down. See what we did. And my best guess is you just need more. You need more experience and practice with multiplication of fractions. The last one, I'm just going to read off the answer. Ready? 20 square inches. Yes? 20 square inches. Okay, I'm going to be honest with you. You need to totally understand this and the area of rectangles and parallelograms in order to make the leap to go into 5, which we're going to spend 2 days on. Some of you will get this right away, and some of you will need some extra time to practice this. Okay? I'm going to hit pause. We'll hand them out, and then we'll come back to the recording. I need help handing these out. Okay. We're back. Okay. I'm going to start you with something that does not appear in your lesson book. And this is this shape here. I want you to look at this shape at the smartboard. And if I were to ask you this question, you ready? How many rectangles, what's the least amount of rectangles that you can make from this shape? Take a look at it. What's the fewest amount of rectangles that you can make from this shape? Jen.
3.
All right, why don't you come up here and show us how you would divide this into 3 rectangles. So Jen's going to come up and show us what she has in mind.
Well, I would think that you would have to do it like this.
Go ahead. All right, now I want you to do this. Number your rectangles, 1, 2, and 3. Does everybody see what we did there? Yes? Okay, I want you to say this word after me. Ready? Decomposition.
Decomposition.
One more time. Decomposition.
Decomposition.
What she did is used decomposition to take what's called a compound shape, which is an irregular shape, and she broke it down into regular shapes, in this case rectangles. This is called decomposition, breaking down the larger irregular shape into smaller regular shapes, rectangles in this case. Can anybody decompose it a second way? This is one way, using horizontal lines. Can you decompose it a different way? Who wants to come up and demonstrate? Nick Nito, Caniclius, Newtonius, Maximus. Label them 1, 2, and 3. This is also decomposition using vertical lines. Good. Can anybody do it with one line going one way and one line going the other way? Gav, come on up. One horizontal line, one vertical line, and then number your rectangles. Hit that X to get rid of that keyboard. Three rectangles?
I can make 3 rectangles.
Too much.
Okay. Oh.
Bud, let me give you a hint. Do you only need to make 2 lines? One vertical, one horizontal, and in doing that, you're going to make 3 rectangles.
Okay.
Think about what the first 2 kids did, and and you're really just combining the two.
Okay. Okay.
You want me to do this?
I don't know. Let me see. He's got one more shot. Oh, you're making more than one line. Delaney, come on up. Watch two here, Gav. There's one, and there's one. Now number your rectangles. Rectangle 1, rectangle 2, and rectangle 3, which looks like it could be a square, but we're not for sure. Okay, that's also decomposition with one horizontal line and one vertical line. Okay, ready? Does anybody see only 2 rectangles? And I'll give you a hint.
Yes.
You could conceivably make 2 rectangles with one line. Ab, you want to give it a shot? Come on up. You have to show everybody. Okay? A picture's worth 1,000 words. You got to show them where you would put that line. Again, the task is to try to create only 2 rectangles with one line. And this is the harder one, there's no doubt. Not everybody sees it right away. One line creates 2 rectangles. You want to let somebody else try?
Yes.
Maddie Bart, you want to try?
Yes.
Okay. Bam.
But I see 3 rectangles.
Oh wait, let me try.
One line's got to create 2. Lily,
Wait,
come
wait,
on.
wait. Yes.
We don't have rectangles anymore, though. We have L's. Lil, you want to come up? Lil's going to be the last person because I'm going to then show it to you. I don't want to spend a lot of time on this. We have to move on, but
I don't think I knew.
this is always the harder one for some kids to see. And it's important for me to show it to you because this is going to be an example of what's called composition. We did decomposition. I'm going to show you composition.
Composition making machine?
I'll show you.
I don't know.
Okay, let me show you guys. I like the way you're thinking, though. It's good. Ready? One line. Okay, let me show you the 2 rectangles at it because you may still not see it. By enclosing this shape, I've created a rectangle here. That's one. And the one that we don't see right away. The larger one is 2. Okay? This is an example of this is called composition, where in enclosing this missing piece here, I've created 2 shapes. All right? The whole gist of lesson 5 is being able to, let me go back to the original figure so I can show it to you again. By using composition and decomposition, we can find the area of these irregular shapes. Okay? So that being said, I want everybody to go to page 3 and see if you could do page 3 all on your own with no help. Try it right now, and then we'll come back to the lesson. Page 3. All right, I think most of you are fine with this first shape. This is 12 and this is 7. My colors are mixed up. And the reason is opposite sides of a rectangle are equal. Raise your hand if you got those two, 12 and 7 done. Okay. For those of you that struggled with the second shape, pay close attention because you've got to get this in order to go on to the next thing. I don't know this piece, and I don't know this piece. What I can do is I'm going to use my other 2 vertical lines to figure this out. Watch. From here to here is 5. if I were to kind of do something like this and break this up by decomposition, if this is 5, then from here to here is 5. That's not my whole piece though. From here to here is 1. So this is 1 plus 5. My vertical lines have to add up to my whole vertical line. So if this piece is 1 and this is 5, that makes this 6. Okay? And my reasoning, all vertical lines have to add up to the entire vertical line. Okay, using that same idea now for horizontal. The whole entire thing is 12. But look, from here to here is 4. That's 4. 4 plus what makes 12?
8.
My horizontals have to add up to my total too. So this is 8, this is 4, that adds up to my entire 12. Lil.
I need something different. Like, on the side, I would say, well, I would add, like, a line over the thing, and then...
You're going to have to come up and show me.
Okay. I did the same thing. With this, then I knew that this would equal this if this line was here, so then I did 4 minus 12, and I got 8.
Okay, so you did it by what's called composition. You enclosed that missing piece. It's the same idea.
Okay.
You're fine. But like I said, some of you will see this right away, and some of you have to practice it more. So go to the next page and let's practice it together. Let's do this one together. We're only going to do, by the way, don't go ahead, we're only going to do number 1 of this, because then we have to move on. All right, so I'm going to go to full screen so I'm not scrolling all over the place. View, full screen. Okay, first let's fill in the lengths of the pieces that they're giving us. A to B is 10 units, so we find line AB and you put in your 10. FE, which is here, is 8. AF is 6. DE is 7. They're asking you to find DC, which is that, and BC. Okay, let's do BC first. Look at all of my up and down vertical lines. I have a 6 plus a 7. That's going to make this whole piece. So what's 6 plus 7? M. Okay, so my B to C is 13. So everybody see how we got that? Just got to practice it. We now have to figure out this. Well, look. We know that the whole entire horizontal is 10. We know from here to here is 8. That's going to make this what? Anna?
2.
Right, because 8 plus 2 makes 10. So that makes this 2. All right? You have to understand this in order to go on to the next thing. But we'll just have to keep practicing it. All right, let's move on. We didn't do the second one, but if you did, I'm going to skip it. But if you did do it, I will tell you that the answer is 40 and 26 would be correct.
Yeah.
Okay, let's move on to the next page. This is a summary page of what we're going to be doing. They call these stages. And you got to break up the stage 3 different ways and find the area. So this kind of tells you what the activity is about. But if you go to the next page 6, it's our actual work page, and we'll do this together. Okay. Part A, they want you to divide the stage into 3 rectangles using horizontal lines, kind of like what we did in the beginning. So everybody make a horizontal line here, and make a horizontal line here. And let's label the triangles. Label it the way that I'm going to show you too, because there's a reason why I'm going from here, making this 1, making this 2, and making this 3. We have our 3 rectangles, right? I know that I'm going to need 3 formulas for the rectangle, so let's just get that out of the way first. 1, rectangle 2, and rectangle 3. And this extra set of lines, you'll see what that is for in the end. Okay, let's look at rectangle 1. Nick, what's the base of rectangle 1? Look again. Right. If this is 2, this is 2. My base is 2. Now the hard part. I don't know what this is. They don't tell us what this is, but they do tell us this whole piece is 9. So we have to look somewhere else in the shape to figure out what this piece is. Jen, what do you say?
On rectangle 2, it actually says that part is 4.
It does. So if this is 4, then this is 4, then this has to be 4. We now have the base and the height. So it's 2 times 4, and that's going to make 8. And don't worry about units yet. Let's just deal in numbers. The reason why I go and make this number 2 is because once you have one tower, you really have the other. These 2 are identical towers. So it's the same exact thing. It's a base of 2 and a height of 4. And that's going to make 8. That makes rectangle 3 our most challenging piece, because they give you a base and you have to figure out the height. First, let's get the easy one out of the way. What's the base? M&M. They give it to us. So it's 7. We have to figure out the height using what we do know and subtracting something else. Do you see it? Right. See, this whole piece is 9, but from here to here is 4. So 4 plus 5 makes our 9. That makes the height of that piece 5. 7 times 5 is 35. So now I have all 3 pieces. What do I have to do to get the total area? I'm still not done. What do I got to do?
You have to add all of them?
Add them all up. 35 plus 8 plus 8. And just be careful and make sure you don't make any careless math errors. You will have access to a calculator throughout the quiz and when you're working by yourself. So if you want to use it even for basic numbers, you can. What do you have there for this, Matthew?
What?
What'd you get as a total?
36.
Yeah, what do you have as a total? Add it all up.
41.
Don't make careless math errors.
Wait.
Don't guess. Kira, what do you got? 51. And since that's our final answer, we have to add the units in now. Circle it. Okay? So that's part A. Now part B is going to say, okay, let's see if we get 51 if we break it up with vertical lines. We should get the same, because you could break it up any way. The area should not change. But you will have different numbers. You'll have different numbers in which to plug into the formulas. I'm calling this 1. I'm going to skip over and make this 2, because this should be identical. And this is 3. All right, ready? look how nice and neat this works out for us. We happen to have a listed base and height for both rectangles 1 and 2. It's given to us. There's no guesswork involved. We have a base of 2 and a height of 9. So plug it in. Get your 18. And if you want to cheat, watch how I cheat. Just put 18 down here because we know they're identical. It's a little shortcut. You're fine. Rectangle 3 is our new one, though. We can't cheat. They gave you the easy ones with 1 and 2, and they left you with a real hard one with 3 because you don't know. Well, you have to figure out both the base and the height. They're two brand new measurements. Let's start with this. Can you figure this out? You actually kind of did it in A. So if you look over in part A, you really do have this measurement. You just don't know you have it. All right, Gab, what do you got?
Well, we need to, since the base of the whole shape would be 7, and...
What are you doing first, too? If you're doing base first, do the height first, this. And then up.
The height, control height is 9. It says that the height is 4, so subtract those, and I got 5.
Okay, that's 5. And if you forgot, we kind of already did it up in A. See, here it is again here. Okay. All right, talk us through the base.
For the base, the entire base would be 7, but since
Time out for 1 sec. I don't mean to cut you off. Look, give us the measurement first, and then tell us how you got it. What do you have for this piece? Okay, you're right. Now go. Why?
The whole base is 7.
Okay.
Since the have a base of 2, apple 2.
Opposite sides of rectangles are equal. So that's how he's getting these 2's. The whole piece is 7, so we know 2 plus the number we're trying to find has to add up to 7. And he's right. It's 3. So now we have, 5 times 3. And you get 15. Add it up, and you should get 51, but just double check and make sure that you do. Yes? 18 plus 18 plus 15. Oh, 18 plus 18 plus 15. What we got? Okay? It works. I'm going to show you one more other way before the bell rings. If the bell rings, just hang for a minute. We're going to cheat a little bit, though. Watch. So I want to make sure everybody's on this. We got as far as completing C in my first 2 classes. Okay, 1 horizontal, 1 vertical now. But we're going to cheat. We've done this one already. Look back at part A. And what was the area for rectangle 1? We did it. No need to do it again.
8.
Was it 8?
Yeah.
Okay, just put down 8. We're going to cheat. We did number 2 already. Look back at part B. Is it 18? Okay, that makes the new triangle or new rectangle this one. What's this side? We've done this.
5.
This is 5. This becomes brand new.
Oh, sorry. I almost did base.
What is it?
5.
It's also 5 because 5, we have to add up to 7. 5 plus 2 makes 7. So now, it's 5 times 5. And if you add 25, 18, and 8, you'll get 51 all over again. Everybody's clear on what the homework is, right? Only 1 and 2, problem set.